Hello, everyone. Today I will be explaining IGCSE Chemistry, Chapter 2. More precisely, 2.1 Elements, Compounds, and Mixtures, and 2.2 Atomic Structure and the Periodic Table. In 2.1, we have to look at the definitions of elements, compounds, and mixtures. An element is a substance that cannot be further divided into simpler substances by chemical methods. All of the atoms of an element contain the same number of protons. A compound is a substance formed by the chemical combination of two or more elements in fixed proportions. A mixture is a substance formed by the physical combination of two or more elements, not in a fixed proportion. Let's move on to 2.2, Atomic Structure and the Periodic Table. Take a look at the objective. Now let's discuss the atomic structure. An atomic structure consists of a central nucleus, which contains the green-colored proton, which has a positive charge, and the red-colored neutron, which is neutral in charge. Next, there are electron shells in which the blue-colored electrons orbit. The valence electron shell is the outermost shell of an element. Let's look at the properties of subatomic particles. You might wonder, what are subatomic particles? Well, it's basically just a collective name for protons, electrons, and neutrons. Let's look at proton first. Proton has a relative mass of 1, a relative charge of positive 1, and it's found inside a nucleus, as I mentioned before. Neutron has a relative mass of 1, no relative charge, and it is also found inside the nucleus. Lastly, electron, which has a relative mass of 1 over 1840, or you could say negligible, a relative charge of -1, and it is found outside the nucleus orbiting in shells. Atomic and nucleon number. Proton number is also known as the atomic number of an element. The number of protons in the nucleus of an atom determines which element it is. For example, an element with atomic number 11 is most likely to be sodium. Every element has a different atomic number, and the atomic number is denoted by the letter Z. Mass number is also known as the nucleon number. It is the total number of protons and neutrons in the nucleus of an atom. It is denoted by the letter A. Neutrons. We calculate neutrons by subtracting the nucleon number and the atomic number. A minus Z equals number of neutrons. This is an example of how we write the symbol of element with its atomic and mass number. X represents the symbol of the element, for example, Na for sodium. A represents the mass number, which is 23 for sodium, and Z represents the atomic number, which is 11 for sodium. Can you try to write the symbol, atomic number, and mass number of boron in this format? You may take help from the periodic table. Next, we have the electronic configuration of elements. Electronic configuration shows the total number of electrons in an atom or ion. The atomic number of sodium element, Na, is 11. The proton number or atomic number is equal to the number of electrons in an atom. So the electronic configuration of sodium atom is 2, 8, 1. The maximum number of electrons that can be filled in first shell is 2. The maximum number of electrons that can be filled in second shell is 8. The maximum number of electrons that can be filled in third shell is 18. 2n squared is a formula used to determine the max number of electrons that can be filled in a particular shell, where n is the number of the shell. E.g., third shell can fill 2 times 3 squared equals 18 electrons. Here's an example for the electronic configuration of sodium, which is 2.8.1. Try to write the electronic configuration of fluorine atom. Write your answers in the comments section below. Moving on, we have the electronic configuration of ions. In a positive ion, cation, the number of electrons is less than the number of protons because the atom lost electrons. In a negative ion, anion, the number of electrons are more than the number of protons because the atom gains electrons. Remember, the electronic configuration shows the number of electrons in an atom or ion. The number of protons or atomic number stays the same, and the mass number or nucleon number also stays the same. Here's an example of the electronic configuration of sodium ion, which loses an electron, and the electronic configuration of chloride ion, which gains an electron. Remember, number of protons and neutrons stays the same, so hence, the atomic and nucleon number also stays the same. Let's move on to Group 8. Group 8 elements have full outer electron shells. They are also called noble gases. They do not take part in any chemical reaction. They do not form ions as they are stable. They are monoatomic. Here are some examples of Group 8 elements: helium, neon, and argon. Electron shells. The number of valence electrons in the outermost shell represents the group number of the atom. E.g., sodium, Na, has 1 electron in its outermost shell, meaning it belongs to group 1. The number of total electron shells of an atom or element represents the period number. E.g., sodium, Na, has 3 total electron shells, which means it's in period 3. Can you determine the group and period number of chlorine, Cl? Its atomic number is 17. Drop your answers in the comment section below. Take a look at the periodic table. Figure out the number of valence electrons and the total number of shells in silicon. Drop your answers in the comment section below. Question time. Pause the video to answer the questions. Answers are at the end of the video.